In this video, we will do further problems from exercise 3.2. The perimeter of a certain sector of a circle is equal to the length of the arc of semicircle having the same radius. So what's given here is, you have two circles with the same radius. So I have taken one single circle because both of them have the same radius. So one, you're given the perimeter of a certain sector. So there is a sector, so I'm defining the sector AB, and the perimeter of this sector would be OA plus OB plus this length, arc length, which is AB, that's equal to L. This perimeter is equal to the arc length of this semicircle, which is, if we define this point as P and Q, then the arc length from P to Q is the arc length of the semicircle, and that will be equal to pi r. So let's start defining. So let's say that let L be the arc length of the sector, and let R be the radius of the circle. The perimeter of the sector, so the perimeter of the sector would be R plus R will be 2R plus L. So that's equal to 2R plus L. Now this perimeter is equal to the arc length of the semicircle. So the arc length of the semicircle is equal to, from P to Q would be pi r. We know the circumference is 2 pi r, so semicircle will be half of it, so it's pi r. Now these two are equal. So given 2r plus L is equal to pi r. So therefore, the arc length L is equal to pi r minus 2r. So you can further write it as L is equal to, take the r common, into pi minus 2. Okay, so what are we asked to find? Express the angle of the sector in degrees, minutes and seconds. So you need to find this angle theta. So if I'm going to define this angle here as theta, then I can say let theta be the angle of the sector. Then we can say that our theta divided by 360 into 2 pi r would be equal to the arc length. So that's the definition, or that's the equation for the arc length. So this is equal to arc length L is r into pi minus 2. So r into pi minus 2. So if we start to simplify this, our r and r will get cancelled. So then you'll be left with theta. So further this will become 180. So our theta is now equal to pi by 2 on the right hand side divided by, let's bring the pi down, pi into 180 will go on top here. So it's 180. So further simplifying this, let's replace the value of pi by as 22 by 7. So 22 by 7 minus 2 divided by 22 by 7 into 180. So that's equal to, simplifying this, so 27 is the denominator, so we can bring it down here. 7 into 22. So this will become minus 14, 22 here, and the 7 will go on top into 180. So again 7 and 7 is cancelled. So you're left with 22 minus 14 is 8 divided by 22 into 180. Further simplifying this, 4 and 11. So the answer would be 720 divided by 11. And that's, if you divide it by 11, you get 65, 5 by 11. Now this is in degrees. So we need to find the sector in degrees, minutes, and in seconds. So let's write it here. So this is equal to 65 degrees. Then your 5 by 11 should be multiplied by 60 to find the minutes. So 5 by 11 into 60, that is in minutes. So further simplifying this, you get 65 degrees, and you will end up with a 27, 3 by 11, that's in minutes. So further simplifying this, you have to multiply the 3 by 11 into 60. So you get 65 degrees, 27 minutes, and 16 seconds. Therefore, the angle of the sector is equal to 65 degrees, 27 minutes, 16 seconds. Question number 9. An airplane propeller rotates 1000 times per minute. Find the number of degrees that a point on the edge of the propeller will rotate in 1 second. Okay, so I have put for you here the picture of a propeller. So if we consider this as a circle with a radius r, so let's call this, the circle with radius r. Now the propeller is rotating 1000 times per minute. So it's going round 1000 times in 1 minute. So if this is the circle, then it's going 1000 times in 1 minute. So let's say the number of rotations per minute is equal to 1000. Now we need to find the number of degrees that a point on the edge of the propeller will rotate in 1 second. So the number of rotations per second would be, if it is rotating 1000 times in a minute, then you have 60 seconds in a minute. So per second would be 1000 divided by 60. So simplifying this, it will be a 50 and a 3. So this is 50 by 3. Now every rotation will have 360 degrees, because we know that a full rotation is 360 degrees. So let's say every single rotation is equal to 360 degrees. Therefore, the angle rotated in 1 second or in 50 by 3 rotations is equal to so the angle rotated in 1 second, or you can say that the number of rotations is 50 by 3 in a second. So in 50 by 3 rotations will be equal to 50 divided by 3 into each rotation is 360 degrees. So your answer would be 6,000 degrees. Question number 10. A train is moving on a circular track of 1,500 meter radius at the rate of 66 kilometers per hour. What angle will it turn in 20 seconds? So you have the radius of the circle or the circular path that the train is taking as 1,500 meters. And the speed at which the train is moving is 66 kilometers per hour around this path. What angle will it turn in 20 seconds? So if we consider just 20 seconds, how much of distance will it cover and what angle will that make is what we need to find. So the speed of the train is equal to 66 kilometers per hour. So we need to convert the kilometers to meters and the hour to seconds. So to do that, this would be 66 into 1000 meters in a kilometer divided by, to convert the hour to seconds, you need to multiply 60 times 60. That would be in meters per second. So we can simplify this, knock off these two zeros. This will become 11, 3 here, then 5. So your answer will be here 55 divided by 3 meters per second. So this means that the train is traveling in 1 second 55 by 3 meters. So we can say distance traveled in 1 second is equal to 55 divided by 3 meters. So the distance traveled, therefore the distance traveled in 20 seconds will be equal to 55 divided by 3, that's in 1 second, into 20, and the answer will be in meters. So this is equal to 1100 divided by 3 meters. Now we know the radius of the circular track is 1500 meters. It's already given to us. If we consider this to be the distance traveled in 20 seconds, then this distance is 1100 divided by 3 meters. So we are asked to find this angle theta. So now what you have is a arc, and so we know the formula for the arc length. So the arc length which is 1100 divided by 3 is equal to theta, this angle theta here, divided by 360 into 2 into pi, which will be 22 by 7 into r, the radius, which is 1500. Let's rearrange this with theta on the left hand side. So if it's theta here, then your right hand side will become 1100 divided by 3 times whatever is here in the denominator will go to the numerator on the other side. So this will be into 360 divided by this 2 into 7 by 22 into 1 by 1500. So let's delete all the common terms, zeros. Then you have a 22 and 11, so this becomes a 2. Then this will become in 3, 120. Then further 120 will become a 60. Then further the 60 is 4 times of 15. So you're left with, and this will be a 2. So your answer is 14 degrees. So our answer is, the train turns in 20 seconds with an angle theta is equal to 14 degrees. Question number 11. A circular metallic plate of radius 8 centimeters and thickness 6 mm is melted and molded into a pie. A sector of the circle with thickness of radius 16 centimeters and thickness 4 mm. So what's happening is, we have here a metallic plate. So this is our metallic plate. So this metallic plate has a radius of 8 centimeters. So which means the diameter would be 16 centimeters. So the radius is 8 centimeters. And the thickness, which is this thickness here, is 6 mm. Now this is melted out and used to create a pie. So a pie will be in this shape. Now a pie is a part of a circle. So the radius of the circle would be this length. So this length, the radius, is given as 16 centimeters. And the thickness of this pie is 4 mm. Now since the same material is used to recreate this, the volume of this plate and the volume of this pie are equal. So if we are going to find their volumes, they should be equal. So what are we supposed to find? It says find the angle of the sector. So first let's equate the volumes. By doing that, we will be able to find this arc length. Okay, let's define V1 be the volume of the circular metallic plate. Now this V1 would be equal to the area of the circle, times the thickness. Now the area of the circle would be pi r squared into the thickness. Now our radius is given in centimeters, the thickness is given millimeters. So we'll have to, when we put the thickness here, we need to convert it into centimeters. So first let's put the radius, which is pi 8 squared, which is 64, times the thickness would be 6 mm. So it's 0.6 centimeters. 0.6. So this would be, the volume would be in centimeter cube. So further, we can find the volume of this pie here. So let V2 be the volume of the pie. So V2 is equal to area of the pie times the thickness. Now to find the area of the pie, if we consider this angle as theta, so it's theta divided by 360 into pi r squared into the thickness. Now we know that this radius is 16 centimeters and this thickness is 4 mm. So again we need to convert this 4 mm into centimeters, which will be 0.4 centimeters. So converting, you get theta divided by 360 into pi r squared is 16 squared into your thickness is 4 mm, so it's 0.4 centimeters. So this is centimeter cube. So further simplifying this, you get theta by 360 into 16 squared will be 256 pi into 0.4 centimeter cube. Now we know that the volume of the circular plate and the volume of the pi are equal because this circular plate has been molded and made into this pi. So their volumes are equal. So we have them both in the same unit, centimeter cube. So we can equate V1 equals V2, which implies our pi into 64 into 0.6 is equal to theta by 360 into 256 pi into 0.4. So we need to find the angle of the sector. So this is the angle that we need to find. So if we are going to, we can cancel this pi and pi here. And if we rearrange this, our theta will now be equal to, let's keep the 64 into 0.6 here as it is. Then we can bring these two terms down. So it's 256 into 0.4. Then this term will go up here to the other side. So it will be times 360. So further simplifying this is, and 256 is 4 times, then you can cancel this 4, so it will be 90. So you have here, and this is 0.3 by 0.2, so you have 3 by 2 into 90, so this is 45. So your answer is 135 degrees, which is equal to 3 pi by 4 in radians. So therefore the angle of the sector is equal to 3 pi by 4.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.